Today we are going to discuss about easier and faster way to adapt Kubernetes in AWS. As you may already aware, Kubernetes is one of the most popular open source projects and many organizations adopting it to run their containerized workload. However, sometimes it may be challenging if you don't have adequate IT resources in your organization. Because of the complexity of the Kubernetes, it may be challenging to adapt. So AWS recently announces EKS Blueprints project that will help you to address some of the pain points you have in your application delivery pipeline and accelerate time to market. So what is EKS Blueprint? So according to me, it's a set of infrastructure as code script organized as a template that help you to provision EKS clusters, bootstrap with all required add-ons to deploy and operate workloads in cluster. So once template is configured, you can use it as a blueprint to spawn consistent environment across multiple AWS accounts and regions. You can find this diagram from AWS documentation. So as you can see, in a regular AWS account with VPC, you can have EKS cluster. So there are several ways that you can create EKS cluster in your AWS account. But the difference with blueprints, so as I mentioned earlier, it's configurable template with all your favorite add-ons to your Kubernetes cluster, and also it's provide help to onboard you and manage teams and configure cluster access easily. For example, here with your Kubernetes clusters, you may use Prometheus Grafana for observability, and for probably the AWS Carpenter for auto scaling, and you may use Nginx for ingress, and continuous delivery you may use Argo Flux project. So adopting all these add-ons to your Kubernetes project and installing them, managing them with all the team onboarding and access management. So that's the difficult part in the managing Kubernetes cluster, right? So in the EKS Blueprint, they provide a template that you can easily define all of these requirements in a declarative way. So it's basically come up with the two forms. You can have Terraform template. Also, this project come with in as a CDK templates as well. So, but today we are going to discuss about the Terraform templates. So let's have a look. So this is the official AWS repo for AWS EKS Blueprint. So you can read the documentation for more information. So if you quickly go through the repo, you can find out many example easily in this example folder. If we just check very basic example here, see, you can simply define your EKS Blueprint module and all these required cluster configuration, what's the version you need, and you can use regular VPC module to if you have existing VPC, you can provide that. If you don't have, then you can create the VPC and provide the VPC ID and all the subnet details. And here you can have manage node group or Fargate profile or custom node group. So everything support here. So yeah, it's and also when it come to Kubernetes add-ons, as we explained discussed earlier, so it's simply matter of enabling all these required. For example, this EKS manage add-ons like VPC, CNI, Code ENS, kubeproxy, all the regular things that we have in EKS cluster. So we can just enable it from like this. And also for the other add-ons that normally we have in Kubernetes cluster. For example, the load balancer controller, metric server, and also as we discussed, the Grafana, Prometheus, and all those things. It's just a matter of enabling them here. So where can we find all these add-ons? So in these modules, Kubernetes add-ons, in here you can find all these current add-on that the project support. And as you can see, there are so many add-ons, even this little short time period added to this project. So we can see the growth of the project, and community keep adding a lot of add-ons to the project. So we can see all these Argo CD, kubeproxy, Calico, Gatekeeper, Grafana, Carpenter, Prometheus, everything. Almost all the popular add-ons available here. We can just find it out here, and we can enable them in the project. Okay, let's have dig into our code. I have repo created here in under my name, so you can find EKS Blueprint. In here I'll go through just the code with you. So I have used that VPC module just to create VPC for my project, and I have defined all the required input parameters for me on the VPC side, and the availability songs. I have public and private subnets. So basically, in the main file, Terraform file, I'll define my EKS cluster version and all things. I'm just go with the regular manage node group for this demo. And the add-ons in here, I use that regular VPC, NI, code ENS, and everything, kubeproxy and CSA driver. Apart from that, so I have enabled Argo CD for my continuous delivery. So I have separate repo for manage my workloads. So I have given my workload repos and the add-on repo where I have defined my workloads and add-on. Apart from that, here I have enable AWS load balancer with Nginx index. So for that I have given my host name and the certificate for that my domain. Apart from that, so for this demo purpose, I have enabled Prometheus Grafana, and it also there's a add-on for external secrets. If you need to manage your secret from AWS secret manager, or public console, so any other with the external secret manager, so you can use this external secret manager operator. So with all those things, let's create our cluster. I'm in my EKS Blueprint folder, the same files you can see here. So I'm going to Terraform init. Okay, terraform and it's done. Yep, I'm going to then terraform apply with my input tfr file. That looks good. We have so many resources creating all the managed node group and the add-ons, for example this like grafana, external secrets. So all the things we have defined, so we can see that terraform going to create each and every resources. So let's apply. Yep, I'm going to approve the change. Okay, now terraform start creating all the resources we have defined in our template. So it's now creating all the roles, policies, IAM resources, secret, and now it's creating the VPC and all the security groups, rules, public subnet, route tables, gateways. Okay, now it's just started creating the EKS cluster. Meanwhile, we can see the progress from AWS console as well. Yep, EKS Blueprint demo cluster is creating status. It will take 10 to 15 minutes to create all the cluster and the node group, and then it will deploy all the define add-ons to the cluster as well. Yeah, while it's deploying, let me explain the Argo CD part and the delivery pipeline in our project. So as you can see here in the main template file, we have enabled the Argo CD and we have defined the workload path. So GitHub for the add-ons, the default AWS samples repo, and for the workloads I have defined my own repo, EKS Blueprints workload. So this is that repo. So inside that Argo CD apps dev, so that's the app I have, Argo CD app I have created. So yeah, in there define the workloads repo and the path that it need to look, teams blue dev teams blue dev. So this is the sample application. So I have simple go application run on port 8080. So I have deployment and service for that, and since I have enabled the ingress controller in Nginx, I have ingress YAML for that. I am deploying it as app dev under my domain. So it's accepting traffic on port 80 and forward into my application here. Yeah, one thing I forget to mention earlier. So team blue dev in here in the main, yeah, we have defined the teams as well. So we have two teams, platform team and application team. So it will create this namespace for us. I define as a team blue dev, so the same namespace I have use for this team blue dev, as you can see. So that namespace will automatically create and my application will be there. And so in here I have defined my quota and all the resources I required, and I have added the current user I'm using for that application team. So this is pretty much easy. So you can with your infrastructure template itself, you can onboard your platform team and application team, and define what are the users that you need to grant access to your applications and platform teams. Yeah, the cluster is still creating. Yeah, normally it will take 10 to 15 minutes to create. So yeah, similarly you can define all the so this is the teams, and you can define multiple workloads, multiple workload repos. So you can add as many as you need with different repos and paths. So it will eventually so sync these workloads with your Kubernetes cluster as soon as the cluster create. So since we are enabling the Argo CD here, so with the single go, so it will create create the cluster and bootstrap all the add-ons and configure these workloads as well. So in 20 to 30 minutes you can have a fully working cluster with all your favorite add-ons installed and your workload configured. So that's the beauty of this blueprint projects. It pre-baked with all the security and best practices as well. It will make sure it will create the required IAM policies and the permission and associate with all these namespaces and the application. So within very short period amount of time you can have a well architect EKS cluster up and running, and you can use it as a blueprint to spin up any number of clusters in any region. So AWS account to spin up your Kubernetes cluster. Okay, it's still creating. Meanwhile, I show you my demo app as well. So I'm using this demo app, simple Go application. to greet the visitor and check the application version. So containerize it and push to my Docker hub, and as you can see in the workloads repo, so I'm pulling it from there. Yeah. So in the documentation also, I have mentioned once the cluster is created, in the Terraform output file you can find out the general uh, platform teams and application teams, the kube config command for that specific team, so you can have that. And this is a general kube config command that you can configure your AWS kubectl, update the kube config to have the access to your cluster. And also in here I have explained how to access Argo CD using port forwarding. And if you like, since we have that ingress control already installed, you can have ingress object as well, pointing to the Argo CD server. But for demo, I have just added how to access it using port forwarding. And you can get the secret we have used Argo CD from the AWS secret manager. Yeah, in here as a next step I am planning to create instead of manually spinning off the cluster from local, we can define GitHub action through Terraform cloud to once we merge PR, also it will review the changes and just apply to spin up this workflows. Yeah, probably as a next video I'm planning to demo that part, how to create that workflow, creating GitHub actions and spin up the cluster via Terraform cloud. Yeah, similarly for observability, we are installing Prometheus and Grafana as well. So using port forwarding, you can access the Prometheus and Grafana to demo as well. So you can see all this instruction in the README file. Yeah, this is the EKS Blueprints repository with all these things, and I have links to the workloads and demo app repositories as well. Okay, looks like cluster created, and now it's creating the node groups, mgn5 node groups. We can check. Yep, cluster created. I think now it's yeah, demand decide state 3, it's still creating. Okay, cluster created and node group also created. Before adding the EKS add-ons, I have added a little bit of weight here. Sometimes I got a couple of errors initially when I tried to spin up the EKS cluster and node group, and on top of that, as soon as if I try to install the add-ons, sometimes node groups may not ready, and it will sometimes giving you some error. So I just added a few seconds of waiting time there, so then cluster will be up and the node group, all the nodes are created and settled. So uh, without any error, all the add-ons can be installed to the cluster. Compute. Node group also. I think I have added 3 minutes wait time, probably it's too long. Yeah, it's 3 minutes probably. Yeah, you can reduce or remove it and try it out. Let me know in the comments if you experience any issues without this. Ideally it should not, but I'm not sure why I'm getting that. Yeah, another 10 seconds. Yep, it's done now. It's installing all the add-ons. It's adding load balancer, external secrets, fluent bit, code DNS, everything we have defined. It's added to the cluster. VPC CNI, CSI driver, Argo CD. Yeah, you should be able to see the add-ons. CSI driver creating, code DNS done, code proxy done, VPC CNI done. Okay, it's done. So as you can see, it's completed, everything completed. So apply completed, 118 resource added. So in the output we can see all our application team configuration. So as I mentioned, so we can use this to configure our group CTL to access the cluster as application team. So if you use that one with this IAM role, so ideally it should be able to access the team blue dev namespace. And you know similarly we have platform team, that admin uh, role as well. So yeah, I'm going to use that ARN to configure my group CTL. I just copy this one, and yeah, as you can see, it's update the context and the group config updated. Let's see. Group CTL get pods all. Yeah, let me reduce the size a little bit. Yeah, you can see all the pods. Argo CD, external secret, scope system, all the nodes, code ENS, everything is there. So probably it will take a little bit of time to create our workload as well, as we have configured Argo CD. Yeah, let's check the services as well. Group CTL get SVC. Oh, yeah. Still it's deploying. I cannot see the Nginx yet. Okay, everything running. I'm checking why load balancer with the Nginx controller not available. We have defined it correct. see any errors as well. Everything pulled and created, scheduled. Code DNS that's eventually created. Please note. Okay, I think now it's created. Previously we didn't see the team blue. Now I can see Prometheus, external secrets, Grafana I can see. Yeah, it's taking some time, I think that's why. Let's cluster to scalar. I can see, yeah, it's coming up eventually. Yep. Now I can see Prometheus and my sample application also, the web app also deployed into cluster. Yeah, that means Argo CD get synced with the cluster as well. Yeah, Ingress Nginx. Okay, yeah, I can see, yeah, 48 seconds ago. Yeah, Nginx Ingress controller also synced with the cluster. Good news. Yeah, everything up and running looks like. So I think we have to do one more thing. Let's get the service and okay, yeah, we can see the load balancer created, Ingress Nginx controller and the load balancer. So we have to update the route 53 for our domain. That's the only manual thing we need to do. That's also we can automate, but yeah, I didn't do that for this demo. Our load balancer is starting from AF8C. Let's go to route 53. Yeah, I have one hosted, so in there I have my domain. Let me, yeah, in there I have a record for wildcard ravi.me. So I need to change what is my load balancer, AF8C. I have to change it. Okay, AF8C. I have selected my load balancer and update it. Yeah, it will take few minutes to update the DNS record and the DNS propagation. Meanwhile, let's find out our application URL. Yeah, appdev.me. Yeah, probably it may not accessible at the moment. It may take some time to propagate the DNS. Oh no, it's updated. I can see the hello visitor from my domain. See, everything is up and running. All the services up. We have checked all the pods up and running. We have created a cluster, so it only took 20 to 30 minutes to create a whole ecosystem. So create the infrastructure and provision the EKS cluster and bootstrap with all the required add-ons like CloudWatch, FluentBit, Argo CD, and Nginx, Prometheus, and also the team namespaces and the access control and the team onboarding and management, that's also covered. So with all that in the single template, we just run it and we have our workloads up and running, so we can access the cluster. We have defined Prometheus, Grafana, and CloudWatch matrices here. So I'm going to quickly show how this CloudWatch matrix we can see the telemetries in AWS. So in the CloudWatch we can find out first I will show you. So in CloudWatch we can see it's already created log groups for the cluster, and also for the under container insights we can see all the our workloads and its the resource allocation and everything. For example, our web application we have deployed, let's try, this is our 2 pods for that web application. By selecting it we can see all the CPU utilization, network, memory, and everything. Yep, we have 2 containers and we can compare, and I think also we can create dashboards, so we can select we can create a dashboard or create new dashboard, and we can so as you can see, the blueprints take care of almost all the hard parts, so it configure everything for us. So also let's try to access our Argo CD. Let me get the secret. I got the secret, and with the time you are watching this, so this will be not accessible, don't try to access it. Import forwarding Argo CD server port 8080. I have copied my password and let's try to access it. Localhost 8080. I can access my Argo CD UI. Username admin. I have given my password. Here we go. We can see the Argo CD UI and all the add-ons we have installed. Also we can see the status here and Team Blue. This is our application. We can see how everything configured. We have Go Web Service at the endpoint, and we have 2 ports. How everything configured, we can simply check. So for the deployment point of view, we already automate everything. So if we need to release new version, we just need to update our workload repo, and we have to update the image tags here. So we can just yeah, in the next videos we will automate that part as well, the cd part automation. So once that build with the new version, we can test it out, and if everything is good, we can roll it out by updating this image tag. So eventually Argo CD will pick it up and sync up with your cluster. Yeah, that's all we have for today demo. So I'll try to do this as a series, and eventually as I promised, I will try to do next the GitHub action, how to configure everything fully automatically with the PR. You can spin up this cluster using Terraform Cloud. Yeah, until then, I will